Hi there, we are Luis and Henrique, and this is our final project for CS51. We are doing a object detection using SIFT algorithm as a base. The SIFT algorithm is divided in 4 steps. The first of them is the scale space extremity detection using the difference of Gaussian. The second is the key point detection, the orientation assignment, and the key point descriptor and matching. The scale space extremity detection using the difference of Gaussian is divided in 2 steps. The first step, we will blur the images using the Gaussian function on the right and create different scales and octaves. The octaves are created by downsampling the image by 2 pixels each time. We are doing it 4 times. The second step is to subtract all the images in the same octave. By that, we will get the edges of the image. The key point detection part, we had to change it. The idea on the SIFT algorithm is to search for the maximum and minimum around the whole image by searching by using the central pixel and searching on its neighbors to check if the central pixel is a maximum or a minimum. We store it as a key point, but for some reason it did not work. We used the following idea of using the Taylor expansion to simplify the key points, removing low contrast ones, by simply getting the first and second partial derivatives over x and y, and using that to identify the edges with the maxima and minima. The orientation assignment is the part where we achieve rotation invariant of the key points. We achieve that by calculating the orientation and magnitude of each neighbor. Then we create a weighted direction histogram of 36 beams. On this histogram we get the peak, which is the maximum value, and all the other values that are in a range of 80% of the peak. On the key point descriptor and matching part, which is the last part, we will create a 16 by 16 window around each key point. Once we have that, we will use the orientation assignment with this. Once we have that, we will use the orientation assignment to get the magnitude and direction of all these pixels around the key point. Once we have that, we will have a 128 dimensional vector. With this vector, we will normalize it and store it for future matching with different images. Now for the last part, we're going to show you a demonstration on 5 different images that shows the movement of a bee and of an elephant. But on the last 2 images, the elephant disappears and the bee rotates, so we want to get the movement of only the bee. Now we're going to run our algorithm in the debug mode so we can save all the images of the entire process. Now that this is done, you can see that a lot of images appeared, and some of them have the blur that we apply, the Gaussian blur in the different octaves that downsample the images. Some are the subtraction, the difference of Gaussian subtraction. You can see here that it's a little hard to see, but all the edges are well defined. With that we get our key points with the derivative, and finally we match it on the different images. As you can see, the elephant disappeared and we found only the bees. This is a little rusty because our project is more focused on the object detection more than on the motion. So as you can see, if we apply this on a larger scale image, this can identify a lot of the details. You can see here, it identifies the letters even on the signs around the building. This was our CS51 Final Project. Thanks for watching.